in chapter 4, lesson 3, this is called functions on page 287 in your textbook. And so functions, we talk about independent and dependent variables. Remember we talked about the independent variable is the one that we would just put in numbers most of the time. It's not affected by anything. But the dependent is like a baby, right? It's dependent. It depends on the independent variable in order to find a number or be a number or exist. Okay, so my dependent variable will change depending on what numbers I put for the independent variable. So in these examples down here, the equation C equals 0.99n represents the total cost C for n music downloads. So your number of downloads is independent. That's just what you do. But that affects how much you pay. So the cost. So the cost, you can't just have a cost alone with nothing to change it. You have to have the number of downloads also to know how much you're going to pay or it will cost. Okay, same thing here. It says the equation D equals 4.5h represents the number of kilometers D Alia can run in h hours. So here again, you don't know how many kilometers she can run if you don't know how many hours she's been running. So kilometers then would be my dependent variable and hours would be my independent because the hours determines how many kilometers she can run. The more hours she's running, the more kilometers she will go. And then this one, same thing. It says the equation S equals G plus 3 represents the final score of the game S after G goals in the final period. So G goals is your independent, and then the final score is your dependent. If you're looking at the equation, your G is inside the equation, so it is your independent variable, and the S is your dependent. This one, H, is your inside equation, so independent, dependent, independent, inside, dependent, outside. Okay? So final score would be depending on how many goals are scored. If it's more goals, the final score would increase. If it's less goals, your final score would decrease. Okay, so that's independent and dependent variables. Let's move to, if you're looking at the guided practice on page 290, this is called function notation. When you see f of x, this is the same thing as y. So f of x is the same thing as y. We have looked at equations before and it says y equals. So if you look at the previous lessons, you might see an equation that says y equals. And we did y equals equations last chapter or last textbook. But now, so for example, this says j equals. It doesn't say parentheses or anything like that. So this would be like y equals. D equals, same thing, like y equals. L equals would be like y equals. These say y equals. Okay, so when it says y equals or f equals or g equals or j equals, that's the same thing as f of x equals. F of x is called function notation. So this is function notation. Okay. So in function notation, it says f of x equals x minus 6. So my equation part is x minus 6. And here they are wanting me to find f of 4. Notice the 4 is where the x was. So what they want to know is what is the value when x equals 4. So all we would have to do is put a 4 here and put it in our calculator or subtract in our head. So 4 minus 6 gives me negative 2. So the value of f of 4 is negative 2. This one says choose 4 values or 4 numbers for x to make a function table. So we're going to make a table for f of x equals 8 minus x. So when you choose x values, it's a good idea to pick low numbers because low numbers are easier to do math with. And I normally choose 1, negative, 0, and then the rest can be positive if I want. And you can pick any numbers that you want, but like I said, the smaller the numbers, the easier the math. So then we're going to take these x values and put them into the function or the equation. So we have 8 minus the x value, which in this case I wrote negative 1. This 8 minus my x value on this one is 0. 8 minus 1, 8 minus 2. So I just take these x's and I put them into the equation. So 8 minus negative 1 would give me 9 for my f of x or y value. 8 minus 0 is 8. 8 minus 1 is 7. 8 minus 2 is 6. So I'm finished with my function table. These are my x values and these are my y values. So then it says state the domain and range. And if we remember, the domain is x, the range is y. So I want the x values for the domain. The domain in this case, in order from small to big, is negative 1, 0, 1, and 2. Negative 1, 0, 1, 2. And my range from small to big would be 6, 7, 8, 9. 6, 7, 8, 9. So here's my domain and range for this function for the x values that I chose. All right, and then so number 3 says a hot air balloon. So a hot air balloon is one of those balloons that you can ride in. It has a basket and there's people. And it might be decorated with stripes or something like that. And there's fire. And it floats in the sky. So here's a hot air balloon. Can hold 2,500 cubic meters of air. It is being inflated at a rate is our, we need to know rate because it's rate of change, of 170 cubic meters per minute. The total cubic meters of air, A of t, that's one of our variables, is a function of the time in minutes, t. So time in minutes is our other variable. Okay, it says identify the independent and dependent variables. A of t is the function value, so that's always going to be your dependent variable. So the cubic total, and also usually when it says total, that's dependent. And so our total cubic meters of air is the dependent variable, and time in minutes is the independent. So independent is t, time, in minutes. So we have t, time in minutes, and your dependent variable is A of t, which stands for total cubic meters of air. Total cubic meters of air. So here's our two variables. And then it says what values of the domain and range make sense for this situation. Okay, so first we're talking about time and amount of air. So it does not make sense that we would have a negative time because you cannot go backwards in time. And you also would not have a negative number of cubic meters of air. So we would write only positive numbers make sense. Or 0. Okay, so only positive numbers make sense. Time, we also have to think about, okay, so time can have seconds, and we can have halves and decimals and all of that. So we can have decimals still. We don't have to have whole numbers. So really only positive numbers or 0 is pretty much the only thing that we can have here. We can have decimals still, and we can have all of that. But sometimes you don't want decimals, and so we would put maybe no decimals. But in this case, yes, you can have decimals for time and for cubic meters of air. So we're fine. So only positive numbers or 0. Then it says write a function to represent the total amount of air. Okay, so our function then is the function value or the dependent variable equals the rate of change, which we said was 170, times the independent variable, which we said is t. So here is our function, and it says determine the total amount of air in 6 minutes. So if we were to put 6 for the time, we would get 170 multiplied by 6, which would give us 1,020 cubic meters of air. Cubic meters of air, because our y value is in total cubic meters of air. So we would put cubic meters of air. So this is the total amount of air for 6 minutes. And that's all I would have to do for this one.